Okay. I am Elena Chistova. I'm presenting our work on presentation learning for hierarchical classification of entity titles. The broad task is hierarchical text classification, which is used to organize large collections of documents or entity titles into hierarchical taxonomies. Our focus is on learning effective representations for classifying entity titles into the large hierarchies. Large meaning deep and wide hierarchies. It is important for many real-world applications which aim to organize entities. For example, you see here illustrations. E-commerce platforms use hierarchies to categorize product names and attributes. Another key use case I want to mention, medical coding systems like ICD employ hierarchical taxonomies for clinical services and procedures. In both cases, the hierarchical classification of the object can benefit from the hierarchy-informed entity encodings. For this work, we utilized a large dataset for product titles from Amazon categorized in the rich e-commerce taxonomy. As you can see in the first figure, the hierarchy spans multiple levels of categories. We aim to accurately classify unseen product titles. There are two basic approaches for hierarchical classification of entities. First, flat classification. Flat classification predicts a single category label per entity without considering hierarchy relations between classes. A benefit is it can be simple and interpretable when you use a simple model, of course. For example, a KNN model is an interpretable and simple approach. We can suggest the top 5 similar labeled entities as recommendations when a user adds a new product in the system. However, flat methods ignore taxonomic structure and can be sensitive to outliers, which are a serious problem in such systems. Second, deep hierarchical classification, it employs end-to-end neural model learning to predict taxonomy structure within the model. However, deep models often overfit on the natural class imbalance in data, lose some interpretability, being black boxes, and constraints to ensure valid taxonomy branches. Both these approaches have limitations. As a compromise, we propose a hybrid approach in which the out-of-the-box text encoder, pre-trained text encoder, is additionally pre-trained on hierarchical classification. For baselines, we evaluated pre-trained fastText and BERT encoders using KNN and deep hierarchical classification. For deep classification baselines, we implemented hierarchical models using the same backbones. A deep classification model, which is depicted in this figure, predicts multiple labels simultaneously, denoting the nodes in hierarchy. The final prediction assigns an entity title to a taxonomy branch and is constructed from top-end predicted node labels along with their probabilities. For deep classification using the BERT, we implement the hierarchy-aware loss function, which penalizes the non-existent branches, relations between classes, the model outputs. We used the titled branch annotations from the Amazon Review dataset. This provides fairly broad coverage of the e-commerce domain with hierarchies up to 5 levels and thousands of classes. As you can see, the largest part of this corpus has close to 2 million titles spanning 11 top categories, with over 12,000 classes at the deepest level, at the level 5. The hybrid method outperformed its baselines across multiple e-commerce taxonomies by training embeddings informed by hierarchy constraints. Our method achieves high accuracy, especially for deeper levels compared to the baseline models, including deep classifiers. The learned representations preserved or improved interlevel F1 while improving the branch assignment accuracy. Again, especially on the deepest level. In conclusion, representation learning is promising for hierarchical classification of entities in large taxonomies. The code of our experiments is publicly available. Let me know if you have any questions. Thank you.
Thank you.